Here's our last video of the series, our last type of equation that we're going to try to solve. And for this one, we're going to talk about how to solve it and then use a calculator for today because we still don't know how to do matrix inverses yet, but we're covering that next block. So you will be able to do this yourself next block. Last video, I talked about multiplicative inverses and how that is actually what you're doing when you think you're dividing by real numbers. We're going to use that same concept here. I'm trying to solve for this matrix X that got multiplied by the matrix 1, 2, 3, negative 1 to result in 2, 13. Just as a visual, what that means is if you were to multiply the matrices 1, 2, 3, negative 1 times this mystery matrix X, you get the result of 2, 13. So we do kind of already know the dimensions of matrix X. It has to have 2 rows to match up with the columns, and it has to have 1 column because that's the answer that we got in the result. So we do know it's going to be a 2 by 1 matrix, but that's really all we know. To do that, we're going to try to divide by the matrix in front of the X. However, instead of division, like I said, we're going to multiply by the multiplicative inverse of the matrix 1, 2, 3, negative 1. The way I'm going to note this is using the inverse notation, which we have already used earlier this year. So I'm going to write it as the matrix, and the inverse notation looked like an exponent of negative 1. Now, when you multiply matrices, because the positioning of it does change the resulting matrix, it is very important that you multiply in a specific order. So if I put the inverse matrix in the front of the left-hand side of the equation, I also have to put it in the front of the right-hand side equation. So I'm going to move this over to allow myself to put in that multiplicative inverse that we need to multiply to both sides. Whatever I do to one side, I have to do to the other. Now, we don't currently know what the inverse of this matrix actually looks like, but that's where we're going to use our calculator for today. So here I have my calculator. Mine is an older version, but the buttons and the order in which you press things is going to be exactly the same no matter which version of the calculator you have. So I'm going to type in a matrix. To enter a matrix into your calculator, you're going to go to the matrix menu, which you can see here in yellow on mine, second matrix. The first column that it shows is matrices that have already been entered into the calculator. So to actually put one in, we're going to go over to Edit, select whichever letter you want to assign it, and then tell it the dimensions. So the matrix I'm trying to invert is a 2 by 2. 2 by 2. It's going to give you enough spaces to put in all of your numbers. And once you've put them in, now matrix A, according to the calculator, is going to be the matrix that we have on our paper here. I'm also going to need to tell it the answer or the resulting matrix, matrix B, which was that 2, 13 that we had originally. So I'm going to quit, go back to the matrix menu. I'm going to call this one B. 2, 13 was a 2 by 1 matrix. And then now the calculator knows that that one is called matrix B. So AX equals B was the original equation we had. But to get the X by itself, we were going to multiply both sides by A inverse. On the left-hand side, when you multiply something by its multiplicative inverse, it equals the identity. So I'm going to call that I for identity, even though we haven't talked about what the identity is yet. We'll do that next class. The identity by definition of being an identity. If you're going to call something an identity, it has to have this property. Identity times anything equals that thing that you started with. So identity times X must equal X if that truly is an identity. So we're just using our definitions to follow along and say A inverse times A is the same as division. It results in a 1, which is the identity, and 1 times X is just X. Now, the right-hand side is the part that we haven't figured out how to do by hand, so that's where the calculator is going to come in. The calculator already knows what A and B are, so we're going to type in on the home screen A inverse times B, exactly what I have on my paper. So to do that, we're going to go back to the matrix menu, and this time we're going to use the matrix in the name column because that is where you actually find the matrices you've already entered in. So I'm going to go ahead and select A, and then we're going to use the inverse notation, which is also the same button, times matrix B. Go back to the matrix menu, select B, press enter. The answer that it gives you is your resulting matrix, in this case, X. Oops, I didn't mean to press that button. So our X, according to the calculator, was 4, -1. Notice how that's the same dimensions we already predicted X would be. So that's a good indicator that we probably did this correctly. If you want to double check your work by hand, maybe you're not sure if you put it into the calculator correctly, I would definitely check by hand, not by calculator, because if you made a mistake in the calculator and then you check it by calculator, it's going to say that you did it right. So let's just check it really quickly by hand. I'm going to go ahead and plug in the value of X to see if it really does result in the answer we were expecting. So our X is 4, -1. When we multiply, it's going to be 4 minus 2, that checks. And then it's going to be 12 plus 1, that checks. We did it right. We found the X.